Hello, I'm Simon Whistler, you're watching TopTenzNet, and in the video today we're looking at the top 10 amazing facts about planet Earth. Planet Earth is an amazing place to say the least, and even though we've been living on its surface our entire life, there are still a lot of things we don't know about it. Many things that we do know are quite awe-inspiring, and what's even more interesting about some of these is the fact that they have wide-scale implications on everything around them. But why try to be so mysterious if we can give you 10 such examples? Number 10. Planet Earth and a cue ball. We all know the Earth is big, there is absolutely no denying that, but when it really comes down to it, we have a hard time coming to grips with its actual dimensions. So in order to make things more relatable, let's look at the mountains. Those of us who have been fortunate enough to see or even climb Mount Everest can attest to the fact that it's incredibly huge and humbling. But most people don't even need to see any of the tallest mountains in the world to know that mountains are big. Now, let's take our mental image of the mountains as points of reference when we talk about the dimensions of the Earth. We know that the average diameter of the planet is about 7,900 miles. It's important to note that the Earth is not actually a perfect sphere, but rather an oblate spheroid. This means that because it's spinning on its axis, the diameter at the equator is bigger than the distance between the poles by about 27 miles. And besides these differences, the planet also has some bumps and dents, but they're much smaller than 27 miles. With this information in mind, if we were to scale the planet down to the size of an average cue ball, we would come to an incredible realization. According to the World Pool Billiard Association (WPA) tournament table and equipment specifications, every new ball should measure 2.25 inches in diameter and only have imperfections that cannot exceed 0.005 inches. By making the proper calculations here, it turns out that the biggest imperfection on Earth can be 17 miles and still fall within WPA standards. While Mount Everest is almost 5.5 miles tall and the Mariana Trench is 6.8 miles deep, if they were taken together side by side, the sum is still below the 17-mile margin. The same thing applies to the differences in diameter between the poles and the equator. Each half of the planet is responsible for its 13.5-mile share out of the total 27, which again is below the 17 miles. So anyone who has ever held a brand new cue ball in their hand and is not amazed by the fact that the Earth is even smoother than that, well, he or she seriously needs to revise their sense of wonder. Number 9. The Earth's crust. If you like the previous example, you're probably going to like this one too. The planet's crust is the only place in seemingly the whole infinite universe that we call home, at least for the time being. And it's not even the whole crust per se, it's just the surface. The deepest humans have ever managed to go was a depth of 7.5 miles with the Kola Superdeep borehole in Russia. Temperatures reached well above 356 degrees Fahrenheit, so it was only the drilling equipment and measuring apparatus that made it down there while the scientists stayed safely on the surface. The actual thickness of the crust, like its temperature, varies from one place to another. The average thickness is about 9.3 miles. It can reach a maximum of 55 miles under the Himalayas and just about 3.7 miles under the oceans. Now, by knowing the planet's diameter to be 7,900 miles, if we were to scale it down again, but this time to the size of a basketball, the Earth's crust would be the thickness of a postage stamp. A postage stamp floating on a ball of molten rock and metal. So the next time you hear someone comparing the planet's crust to that of a chicken egg shell, know that that information is entirely false. The planet's crust is far, far thinner than that. If the Earth was the size of an actual egg, the crust would probably be even thinner than the thickness of human skin that peels off after a sunburn. And since the crust is also broken up into pieces that we call tectonic plates, it's even easier to understand how and why continents move around so much. So now that you know these two pieces of information about the crust and the actual size of the Earth, how do you think we fare in size here on Earth in comparison to bacteria on an actual billiard ball? Number 8. Earth's heartbeat. With the previous two entries on the list, would it really come as a surprise to anyone that Earth might have an actual heartbeat? Well, yeah, it probably would actually, and this fact isn't actually true, but the planet does have something closely resembling one. Every moment of every day, Earth is going through roughly 2,000 thunderstorms everywhere on its surface, and these thunderstorms produce roughly 50 lightning strikes every second, and in turn, each of these lightning strikes produces a series of electromagnetic waves that are captured and then bounce between the planet's surface and the lower ionosphere, some 60 miles up. If the wavelength is just right, then some of these waves combine and increase in strength, creating a repeating atmospheric heartbeat. a phenomenon known in science as the Schumann resonance. This phenomenon has been known about for a while, but in 2011, researchers came to realize that this resonance isn't just confined to the planet's atmosphere, since some of the waves actually extend more than 500 miles into space. On a somewhat similar note, a Dutch artist by the name of Lot Gieven, in collaboration with geoscientists from the German Research Center for Geosciences, have recorded the sounds made by the planet deep inside its crust. The recording was done in Germany in a hole similar to the one in Russia that we mentioned before. The German Continental Deep Drilling Program, or more commonly known as the KTB borehole, goes to a depth of 6 miles inside the Earth's crust, and here scientists were able to capture the sounds made by the planet. Some have described these sounds as a melancholic howl or a bell-like alarm detonating histories in the making. Number 7. The amazing story about oxygen. It's no real mystery that Earth hasn't always looked like it does today. In fact, our planet is in a constant state of change even at the current moment. And for the better part of its existence, the conditions on the surface have almost always been different to how they are now. So with this in mind, let's talk about oxygen and how it got here. Oxygen became predominant in the atmosphere roughly 2.3 billion years ago during an incident called the Great Oxygenation Event. Before this time, oxygen levels were marginal at best, making up about 0.02% of all the gases in the air. But during the GOE, it reached levels of above 21%. This big rise is thanks to a tiny organism that is still alive today, the cyanobacteria, or more commonly known as blue-green algae. These organisms are not actually algae, as their common name might suggest, but unicellular bacteria that can manufacture their own food. They live in water, form huge colonies, and use photosynthesis to turn the sun's rays directly into energy. A byproduct of photosynthesis, as some of us probably know, is oxygen. Over billions of years, these tiny creatures inhabited the world's oceans, releasing more and more oxygen as they multiplied and spread. It's safe to say that we owe these cyanobacteria for our very existence and the world in which we live today. It is, however, important to note that this new change in the planet's chemistry did not go as smoothly as some might think. For starters, oxygen was toxic for all other living creatures on the planet at that time and nearly drove all previous anaerobic life into extinction. Secondly, the growing amount of oxygen in the air reacted with the already existing methane, which was in abundance at the time, which created CO2. And since methane is 25 to 30 times more potent as a greenhouse gas than CO2, Earth went through a severe cold spell that lasted for 300 million years and almost drove even the mighty cyanobacteria into extinction. Lastly, the high levels of oxygen triggered an explosion, so to speak, in the number of minerals on the surface of the planet, minerals that otherwise would not have existed if it weren't for the blue-green algae. More than 2,500 of the total 4,500 minerals now common on Earth appeared during the Great Oxygenation Event. So the next time you think of humans as the only species capable of changing the planet beyond recognition and having the capacity to drive life, including itself, into extinction, well, think again. Number 6. The origins of life. For all the credit we can give our men and women of science when it comes to all the discoveries they've made over the years, we still have to take into account the fact that we know surprisingly little when it comes to life and how it came into being. Up until fairly recently, we believed we knew with a relatively high degree of certainty when life first appeared on Earth, and we had our presumptions on how it happened. But it seems that this theory has now changed. According to a recent study, we can now move the appearance of life back by another 300 million years, bringing it quite close to the moment when the planet actually formed some 4.5 billion years ago. If the research is confirmed, then it would seem that life formed 4.1 billion years ago from a primordial disk of dust and gas surrounding the sun just before the Earth started forming. The researchers came to this conclusion after observing tiny specks of graphite trapped inside zircon crystals. This graphite is usually associated with signs of life. Another theory that can account for its existence in the crystals is a massive meteor impact. But given the amount needed to explain these findings, it makes the meteor theory highly unlikely, though not entirely dismissible. If proven true, however, and life is as old as this new evidence suggests, then it would seem it's even older than the moon itself. With the right ingredients, life seems to form very quickly, said Mark Hamilton, a professor of geochemistry at UCLA and a member in the study. Number 5. Two planets become one. Have you ever thought about how the moon was formed? Probably because it's visible in the sky almost every night, people have grown accustomed to seeing it and don't give it a second thought. But the moon's history, and especially its birth, are amazing and terrifying to say the least. Back in the early days of the solar system and soon after our planets began to take shape, fate would place young Earth on a direct collision course with another planet that we now call Theia. Even though it's hard to know for certain if this actually happened, there are strong indications that it did. According to calculations, this sister planet of ours was roughly the size of Mars, or slightly smaller, and because of the still unpredictable and chaotic nature of the solar system at the time, it was flung in the direction of Earth. In the aftermath of this collision, two things happened. The two planets merged to form this one that we are standing on right now, and secondly, much of the debris that was flung into space came together and formed the moon. Now, as we said before, this collision theory is not certain, but the relatively large size of the moon as compared to the Earth points to this hypostasis. Interestingly, the rocks brought back during the Apollo missions are virtually indistinguishable from those found here on Earth when it comes to their oxygen isotopes. The theory also explains our planet's unusually large core as compared to the other rocky worlds in the solar system. Number 4. Shifting poles. No, this has nothing to do with voting or elections, it's about the Earth's magnetic field. Thanks in large part to our planet's larger than usual molten core and its relatively fast spin on its axis, both of which may be the result of the previously mentioned collision between Earth and Theia, our planet has a very strong magnetic field relative to its size. In fact, only Mercury of all the other planets has a magnetic field, but it's far weaker than our own. Venus doesn't have one, even though we're pretty certain that it's got a molten metal core. Scientists believe the reason behind this is because Venus has a slow rotation around its axis and the temperatures inside are more evenly distributed. Scientists believe that Mars did have a magnetic field once, but its metallic core has since cooled and solidified. In any case, our magnetic field keeps us safe from the sun's deadly solar radiation. It keeps our atmosphere from being blown away into space, and it gives us the beautiful northern lights around the poles. But over the past century and a half, scientists have come to realize that this magnetic field is weakening. As it turns out, the magnetic poles of our planet are shifting. This means that someday in the future, north will be south and vice versa, and the process, well, it's already begun. While in the early 20th century, the poles were moving at a rate of about 10 miles per year, today this speed has increased to 40. There's no real need to panic though, since this phenomenon has happened hundreds of times before. In fact, over the past 20 million years, the poles have shifted every 200 to 300,000 years or so. The last time it happened, however, was more than 780,000 years ago, so we're due for another one. And according to the fossil record from previous pole reversals, it seems there were no major changes in plant or animal life. What we would expect to see in this several century process would be an increased vulnerability to solar flares that could knock out entire power grids. Holes could be made in the ozone layer, exposing us and the environment to higher degrees of radiation. There would also be more than 2 magnetic poles at a time scattered all across the face of the planet, leading compasses to spin uncontrollably. Some animals could become disorientated, and we would see the northern lights in unusual places. The actual time frame here is nowhere near to being exact. Scientists are still having a hard time understanding all the inner workings of our planet, but estimates say that this shouldn't take more than 1,000 years or so, probably even less. And before you say anything, it's important to note that from our planet's perspective, a millennium is a literal geological instant. Number 3. Mother Nature is an expert at recycling. Over the many millions of years, Earth has become an expert at recycling. If given enough time, our planet has and will continue to reshape itself in a continuous cycle of renewal and rebirth. Every natural system on Earth is involved in this process in one degree or another, and the whole thing could take hours to explain properly. But because I know your time is valuable, I'm going to keep it short. Let's start with life then. As time marches on, organisms grow, develop, and multiply, and then they eventually die. Their remains fall on the ground and become the very soil on which they once drew their nourishment from. Layer upon layer of this soil is produced, one on top of the other, slowly but surely turning into stone. This bottom layer of stone moves along with the tectonic plates they're sitting on, eventually sliding underneath one another or becoming a mountain if it ends up on top. If this rock layer turns into a mountain as two plate tectonics bump into each other, over time rain, wind, and many rivers, as well as many other natural phenomena, grind away at that rock, eroding it and washing it out to sea, where it sinks to the bottom and turns into sedimentary rock on the ocean floor. Once here, it again transforms into metamorphic rock due to the very high heat and pressure, and eventually it ends up in the upper mantle of the Earth in a process known as subduction. Here, this rock is turned into magma, which eventually finds its way back to the surface via an oceanic ridge system or through the many volcanoes that dot the Earth, and then the cycle repeats itself. Now, this whole process has been oversimplified here, but this cycle that the rock goes through not only recycles carbon across the globe, but it also provides the nutrients necessary for life to thrive in abundance. If it weren't for this process, life's chances on the planet would be severely compromised. Number 2. The Earth is growing. There is a theory circulating out there that states that the planet has been in a continuous process of expansion and contraction throughout its entire lifetime. Known as the expanding Earth theory, it says that at some point in the past, Earth was 80% smaller than it is today, at which point the continents formed its entire surface. Then it began expanding, forming the ocean floor. While the theory does seem to have some intriguing concepts, it does have a lot of scientific inconsistencies and is extremely unlikely. What we are really talking about here when we say the Earth is growing is the fact that our planet takes in roughly 60 to 100 tons of cosmic dust every single day. This can't really come as a surprise to anyone, since this is the exact same process through which all other heavenly bodies in the universe have been created since the dawn of time, including the Earth itself. But we don't ever really think about this happening now. Well, even though it has toned down a bit since the early days of the solar system, the process is very much alive. Even if space seems to be empty, it's really actually littered with lots of fine particles of dust, and these particles get swept up by our planet and in a sense become a part of Earth. Only a small fraction of this material actually leaves a visible trail in the sky, since most of it is too tiny for that to happen. Now, even though scientists have been aware of this phenomenon happening for a while, only with the advent of more sophisticated technology did they come to comprehend its actual scale. Researchers are now looking at what effects these particles are having on our environment. For starters, it was observed that these particles are incremental in the formation of the highest clouds in our atmosphere. It also acts as fertilizer for phytoplankton and can affect the ozone layer's chemistry. But these effects can just be the tip of the iceberg, and scientists are trying to figure out cosmic dust's many other implications. Number 1. But it's actually getting lighter. How can this be? I mean, we've just concluded that the Earth takes in about 30,000 tons of space dust every year, so, well, how's this possible? It's not like we're throwing stuff into outer space, well, not much at least, and it's not like we're using any of that weight to build stuff, since that mass still adds up to the overall load of the planet. Well, as it turns out, Earth is losing mass via two major ways. One is through its core, as it consumes energy in the form of heat, but this loss accounts for just 16 tons a year. The real mass loss comes in the form of hydrogen and helium. These two gases are the lightest in the universe, and oftentimes they simply float away from the Earth. They do so at a rate of 95,000 tons of hydrogen and 1,600 tons of helium every single year. So even though we get 30,000 tons of dust, we lose 97,000 tons of gas. Now, in terms of hydrogen, we don't really have to worry about that one too much, because by the time that's all depleted, the sun will have died out and there'll be no life on Earth to speak of. Yay! But helium is another matter. Even though it's the second most abundant element in the universe, it's disappearing here on Earth. We're now using it on Earth for a huge number of things, and there's only so much to go around. So I really hope you found that video interesting. If you did, please do hit that thumbs up button below, and don't forget to subscribe for brand new videos just like this every day of the week. Subscribe button on the screen as well as below the video now. Also, if you are looking for something else to watch, please do check out some of our other videos that are over there on the right. And as always, thank you for watching.